Hello, and welcome to Prototype and See, the podcast for designers, engineers, and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and bespoke production parts. And in this series, we'll be sitting down with some of the world's most innovative companies to discuss and find out how they go about bringing new products to life. On today's podcast, we have with us Patrick Wyatt, who is the Chief Product Officer of a company called Varjo, which is a Finnish company working in the VR and XR hardware space. Welcome, Patrick.
Thank you, James. Nice
How
to be
are
here.
you?
Yes.
You okay?
Very good, yes.
Yeah, good. So I guess we'll just start off with a bit of an intro to you and the company, what you guys are doing, and yeah.
Sure, yeah. So Varjo, it's spelled V-A-R-J-O, but the I is in Finnish a J.
Okay, and that's a Finnish word, is it?
It is. It means shadow in Finnish.
Shadow.
I'm not a big Finnish speaker myself, but I promise one of my colleagues it really does mean that.
Okay.
So we make mixed and virtual reality technology, so hardware and software that's used for principally mission critical training by enterprises and governments. So think about how you train an F-35 pilot, for example.
Yeah,
kind of thing.
yeah. Okay. And what's like the difference between VR and XR, and like what do those terms mean to people who don't like work in that industry?
Great question. So you've got virtual reality, which is seeing things that are not there.
Yeah.
You've got mixed reality, which is how you can layer together things that really are there, things that aren't there. So for example, think about the world we're in right now. You could be you're the real James, and there could be around you a virtual backdrop. Okay. So if we can blend in real things and virtual things together, that's called mixed reality.
Okay.
You might also hear words like augmented reality as well.
Yeah.
And that's kind of sort of putting like layers over things, like data layer, like in smart glasses.
Okay.
And then XR is just a term that means all the above mushed together as a shortcut, right? So it's like X rather than M, A or V.
Yeah. Okay. All right. So what about your product is particularly innovative or exciting or unique?
Yeah, so I said, we make these training solutions. So our headsets our main product is a headset, mixed reality headset.
I believe you've got one.
I've even got a physical thing here to look at. So this is the flagship product, which is called the XR4 headset that we make. And this is used, I was saying, for training, principally, I'd say these days, pilots or other important mission training. And this is a headset which is a really high-end enterprise government-grade headset. So it's not a consumer headset.
Yeah.
And it's one that we make entirely ourselves, sort of from the ground up. We're one of the few companies in the world who's got kind of a full stack, if you like, for the products. So we design all the optics, the electronics, the cooling, the mechanics, the ergonomics, the whole thing in this product targeted for a certain use case. And what sets it apart is just it's the highest fidelity experience you get out there.
Yeah.
These are headsets which are not they're powered by PC graphics. So you plug them into a PC and run it. So that's why you can't try it on today because we haven't got a big server next to us. But that gives you the ability to run really, really high resolution, really high performance graphics.
Okay, I believe you refer to human eye resolution graphics. So, I mean, my understanding of that term would be that essentially it looks like the real world. That's
a fair proxy. So think about the eye being a very complex thing, in fact, where you've got a certain resolution native to the eye. And in general, the eye's got highest resolution in the middle. So if you look straight ahead, you can see probably between sort of, depending on your vision, between sort of 50 and 70, what we call pixels per degree. So right in the middle of your field of view, you can see really high resolution.
Yeah.
At the edges, it's less. It might be like 10, for example.
Okay.
So when we say human resolution, we mean we can render on the screens a resolution which is appropriate to your eyes. So you couldn't see more detail in reality than you could see on those screens.
No.
And so the resolution's high enough, which is not a thing you can do on consumer headsets, for example, which is not at that level.
Yeah. There wouldn't be the same demand for that from a consumer headset, I imagine.
I mean, everybody want that. It's a very desirable thing. Who wouldn't want human resolution?
It's just so expensive.
It's both expensive, the component's expensive and high end, but also to render those graphics themselves is very demanding. So you'd have to have really big PCs next to it, all those kind of things. And it's not so practical yet for consumer grade headsets to do that kind of thing.
Okay. And rendering the graphics is more driven by the computer hardware or the headset itself? Like, which is delivering those resolutions? Or is
it's a full pipeline. So what we have in the headset here, we have screens, displays that show the content. Think of like a very shrunk down TV screen almost, right? With certain resolution to it. It's about 4K by 4K per eye.
Yeah.
And then we have cameras in the front which capture the real world,
right,
and pass that back. And then on the PC, it's all combined together into one overall image where you've got the virtual content coming from, like, say, a game application or a graphics engine.
Yeah.
You've got the real world content from the cameras. We mush it all together in a way which is complicated and realistic, and then we put it back on the screens in the end. And so it's the pipeline from the quality of the cameras, the quality of the rendering, the quality of the screen in the end that makes the experience be what it is.
Okay. And you manufacture these products yourself in Finland,
So we design these products, and then we have actually dual manufacturing tracks for this depending on the customer base. So for the customers who are more, let's say, the enterprise customers, so using it, say, for design purposes, etc., we manufacture these with an outsourced partner. So they do this assembly and manufacturing. For our government customers, which are sort of very security conscious, we bring that manufacturing, the final stage, back in-house in Finland, where we do all the assembly, calibration, testing, etc., for the final packaging of it together. Okay. And that's actually a really important part of our value prop for those customers, because when you buy a consumer-grade headset, they're all made in the first way, right? Whereas for us, having control over our manufacturing supply chain is really important for us. People know, like, what's in it, those kind of things.
Okay, because those customers are particularly sensitive about the data that the headset is potentially generating, and
there's a few different senses they have. So there's a question around sort of supply chain security and making sure that they can still get the stuff, right, in case of disruptions.
Right, yeah. Which is increasingly a concern for people.
There's a question about sovereignty as well. So these products end up in quite important applications.
Yeah.
And the question about security all at once. And so these things together. And so think about our products being deployed on the heads of the F-35 pilots around the world, right? The thing where you want to be very sure what's in it at that point, right? So you want to have a partner who manufactures, assembles that in a NATO country, has the ability to really control that final part of the supply chain. Okay. Not true of all customers, but those ones which we care about mission critical stuff, that supply chain aspect is important to us. Yeah.
Okay. And then tell us a little bit about the actual design and development process itself. Like, how difficult is it to develop a product like this?
Well, as I said, I think we're kind of unusual that we do make the full stack of things. So typically most electronics manufacturers would take a reference design from a platform, let's say, platform from Qualcomm, somebody else, and then build around it. Yeah. Whereas we're actually manufacturing, we're designing all the things almost from the ground up ourselves, and we do that for flexibility. Right. So the more you work for reference design, it's actually much faster and cheaper to do. Yeah. But we can retailor our thing to our use cases because we have full control over all the components in the stack. Yeah. Now that means it's actually a much bigger effort in terms of design and prototyping and the whole cycle of that product, if you like. So it starts probably a product program for us lasts about 3 years. Right. From thinking what we want to do, starting talking to the component vendors, putting a product concept all the way through to mass production at the end. Yeah. It's quite a long time, right, in this world.
And mass production is, what kind of quantities are you talking about? I mean, because I can't imagine it's...
Yeah, well, we're not talking about tens of thousands, hundreds of thousands a year, exactly, yeah. We're talking about, a number like a tenth of that, right? Yeah, that kind of order of magnitude.
Okay. And that, you mentioned as well, you do both the hardware and the software side of things.
Yeah. And software means both the integrated software, so it's running on the headset itself, but also on the PC that goes with it. And so of Varjo's engineering team, probably 3/4 are software engineers and 1/4 are hardware engineers, because most of the secret sauce in the end comes from the software side of things. Yeah. But the hardware is the enabling factor for all that.
Yeah. Which would you say is the more difficult of the two, the hardware side or the software?
Well, I'm going to offend at least a quarter of my colleagues by saying one or the other in this question. Right. I think they have very different challenges, right? So I think I've worked most of my career in a software background.
Okay.
So this is my first hardware product to build.
Yeah.
Doing that for about 4 years. The hardware life cycle it's hard, right? Just because I think on the one hand, you have to project forward the use cases quite a long way in time.
Yeah.
That lengthens the cycle. And I think early in the day, the Varjo, we weren't quite sure actually who we were building it for. So you had to make a guess, build something, and then you'd find out 3 years later whether you had the right product market fit for that. I think now we have a more mature sense about who our customers are. And so it's actually a bit easier to say, we know what they want, we can build for them. But certainly that time horizon's very long.
Yeah.
I think another problem is that, the mistakes you make. I think in the software world, you make a mistake, you just change it.
It's easy.
It's very, very easy. And so
cheaper.
And so you can much more, I think, fluid about your product process. In the hardware side of things, you make a mistake, you're basically stuck with it, right? Typically, right? And always make a very big change later on. And so that kind of structure and making choices is very important early on in the process too.
And how closely do the two sides of the business work? Do they feed back into each other? Like the software team are demanding certain things from hardware, and hardware are saying we can't, or we can, or
the hardware team always says no in my experience,
right,
but how it goes.
Okay.
So typically what happened would be there would be a bunch of things that are possibilities from different component vendors. So let's say, what is the resolution displays?
Yeah.
There are certain facts out there about what's available and not available. And the hardware team would go out there and they're trying to source different things, and we think about the pros and cons of that stuff.
Yeah.
And that would kind of provide like a baseline of the components we can use.
Okay.
And then the question is, okay, how do we think about the features on top of that? So things like, by feature, I mean something like in mixed reality, you might often want to blend different kinds of content together.
Yeah.
So I might want to say, everything which is within 2 meters from me, I want to have in coming through real, anything behind that should be virtual.
Okay.
And that would rely upon, in this case, on a depth sensor. So we use a LiDAR to do that. There's a LiDAR in front of this headset that's here, which allows you to separate out what's near and far.
Yeah.
And that would be the kind of thing where the software team actually lots of views about, what kind of resolution that requires, what should be the frame rate of that, which would influence how usable it would be later on for the feature side of things as well.
Yeah.
So we're always kind of thinking what's possible, confronting against what features you might build in it, going back and trying to see, what's the balance of those two things together in the perfect world.
And then once you have the headset, how easy is it for the customers themselves to create the worlds that they're looking to replicate? Or is that something that you guys have to help them with as well?
So we don't build the virtual content for them.
Right.
And that's kind of that's their job or the other supplier's job.
Okay.
So typically in a simulator, what would happen would be have a bit of software called the image generator, which is what creates the virtual world.
Yeah.
And that's a big bit of software which has been around for 20, 30 years.
Okay.
They run these domes as well.
Right.
So think about training being, in the past, it would have been done either live or in a simulation dome full of projectors.
Yeah.
So that software comes from a third party.
Okay.
And we help the integration of software with our headset, making sure it all works nice together.
Yeah.
But it's still a separate bit of software.
Separate bit of software. Okay. So, and who I know you've spoken about F-35s. Obviously, we can see that maybe like government, armies, defense customers. Who else needs this?
So the headset is used historically for a bunch of applications across, let's say, high-end enterprise applications, including, let's say, design. So how do you design a car in virtual reality before you start making the real prototypes of it?
Okay.
I think more and more the business is around training.
Right.
And that is training, principally for government use cases, principally for air right now. But I think also expansion there for other parts of the world. So like ground training, how you train a tank crew, for example. How you train somebody thinking about controlling the fire from a plane on the ground, all those kind of things. So I think we've seen more and more that sort of government, mission critical, first responder training as being the focus of this, because they're the ones for whom the quality experiences are so important. The stakes are so high in a way. They value the kind of technology we can bring there. Okay.
And what are the advantages? I mean, some of them are obvious, but maybe it's better for you to tell us just for because you're here.
Yeah.
Like, what are the advantages of using this?
Yeah.
Rather than kind of real world training.
Okay, rather than real world training. Yes, it's a great question to ask. So, I mean, real world training is got two problems to it. One is it's expensive. So I think of the price of flying a fighter jet around the world, right?
Yeah.
Or even practicing in a tank. But probably even more important than that, it's just very hard to create the scenarios you might face in the end, because they're very dangerous scenarios. And so the idea of setting up a real world live fire exercise in these things is, obviously it's done, but it's extraordinarily complex to do, requires months of planning to get there. And so the opportunities of doing that are quite limited. So you'd be surprised to see how little real training actually is done for those cases, because it's so difficult to do. So if you can simulate things, that's obviously really valuable. And simulation happens.
How valuable is it? Like, because obviously the people that are in those situations with your headset on, they know it's not real. So their behavior is going to be slightly different than it would be should they have like skin in the game.
Yeah, no, for sure. Sure. I mean, I guess that's where what that sort of intangible quality of immersion comes in. The idea that the visuals and the responsiveness and the graphics too are so real.
Yeah,
that, you might have played a game in the past, but you watch TV, you watch a game, and in the end, your mind's in it, right? At that point.
Yeah.
And these sessions can be quite long. They can be something like a 2-hour session in a training mission. And so the idea is that person is like so immersed, then they forget
it's okay. So how does your product enable that realism then? Is it solely through this human eye resolution graphics, or are there other elements that are involved?
So I think part of realism is about the graphics, and the graphics are both about the real world quality and also the virtual world quality. And it might be surprising to think, but the hardest part of mixed reality actually is capturing the real world in the right way.
Right.
Computer graphics are really good these days. You actually can create a model of the virtual world that looks absolutely perfect, and you render it really high resolution. What's hardest is to get the capture the world around you in a convincing way.
Okay.
And so getting the quality of the mixed reality components, and to give an example of that, in a cockpit scenario, what happens is you sit in a real cockpit, so a full mock-up of an F-16 or whatever else, and what you see out the window is the virtual world.
Is the virtual world.
But what you feel with your real world, hands and control are real controls.
Okay.
And that's really important, because trying to use controls which aren't really there is just really bad. That's not a good training experience, because the haptics aren't there, all those kind of things. So those really high-end experiences they're mixed reality, so you can feel the real stuff. And then you'll be able to do things like read the real dials, right, through the cameras. You get the resolution and crispness sharp enough, have no latency or lag or camera drag and all that kind of stuff. So I'd say the quality of the VR content is like the best out there and is up there. The quality of the cameras, in a way, is what sets it apart, and how do you make it that real content be convincing, if you like.
Okay. And the cameras are on the front of the headset, and they're filming what you would be able to see.
Yeah, exactly. So I'm here and I'm full demo. Here's the headset. I'm looking out. I would be seeing right now the real James, but behind a virtual world, for example. And the cameras are capturing you. And what these cameras do, they have autofocus lenses in them. So think about the real world. If I hold up a bit of paper then next to you, move back and forward, it goes in out of focus, doesn't it?
Yeah.
And so what you want to do with the camera also is make sure that camera can change its focus according to what you're looking at. In order to do that, we have to, with cameras on the inside of the headset, track where your eyes are looking all the time. And we have to figure out what direction you're either pointing in. And we figure out how far away the thing is using depth sensor from what you're looking at. And then we adjust the camera focus in real time in order to focus on that thing. Which is what the human eye does all the time. But we're trying to mimic that, basically. And this is the only headset that has that kind of ability to have that autofocus nature of things. That makes it really sharp all the time.
And these are all things which heighten the realism of the experience.
And in some cases, it makes stuff readable. So let's say you're in a plane or somewhere else, and you've got a knee board with some data on it. You want to be able to read that paper, whether it's here or here. And so if you can't reach that bar, it's just useless. And so you think actually, they're not so much like quality of things, actually hard bars for passing the test to make this thing useful.
Okay. In the past, I've had a go not with your headset, but with VR headsets.
Something rubbish, I assume.
Well, I mean, you can tell me that, but my experience of it was that it made me feel nauseous, unwell. Is that something that people report after wearing your headset? Is that a common problem? Or
so nausea typically comes from when you're getting different signs from different parts of your body all at once. So let's say you're either seeing one thing, but you're feeling something else. And that can come about through basically problems in the quality experience.
Right.
So, for example, if you've got things where you've got the frame rate of the content's too low, like it's juddering, that can cause you to feel sick. Or if when you move your head around, it doesn't update fast enough what you're seeing. And so that's why things around getting the integration quality really high, around how snappy the whole thing is, are really important for minimizing the effect of this kind of thing. That's what we do with the partners we work with to get that. I would say in general, I mean, pilots are pretty tough, right? They're used to pretty extreme feelings.
What are you trying to say?
Exactly. If you were exposed to all those G's, putting on a headset wouldn't be the big problem for you. But I think it's the quality of the final integration that makes the experience just be smooth and minimizes those kind of effects of dissonance, if you like, between different symptoms you have.
Okay. And does that require then, so you spoke about them being sat inside a real cockpit. Does that also need to move with
a motion platform, for example?
A motion platform. Is that necessary or?
So some have motion platforms, and that's definitely a thing we support. So in the motion platform case, we would take information about the position of the motion platform and cross it with the position of the headset to create the right images in the real time. Not all do. And in fact, I think,
but that is something that you can accommodate and implement into. And does that present any specific challenges?
Not particularly. I mean, it's one more bit of data to integrate into the signal about where you're looking. You've got to know where the platform moved to in real time. But it's a technical problem. It's not a big challenge, really.
And what's the response been so far from your customers and the people using it?
Well, this has been going, we've been working in the sector now for 6-7 years. And these projects, they always begin with somebody testing out a new thing, sort of a little phase where they have someone in the corner of a lab trying capabilities. And then they start to do like real world testing. They take it to pilots, right? And say, okay, what do you think of this? And the question here often is like, can it replace your current training scenarios? So it typically doesn't replace flying a real plane. They'll do that anyway. What it can replace or augment is other virtual trainings. Let's say being a simulation dome. And they say, well, can it get to that level I can get in those kind of things? And then when they say it does, at that point they start thinking, okay, how do you deploy this? How do you field it? How do we get this thing like out there on bases, even on aircraft carriers sometimes, like out there like in the wild? And so I think we see ourselves moving through a journey where we start with like feasibility and like proving the point. Then you kind of validation, and then finally in deployment phase. And now in the last few years, we're in these big deployments now. So we have several customers who are sending out hundreds of these things to real world locations where they haven't got like massive tech staff on site. It has just to work every day for 12 hours a day, session after session, like delivering those kind of experiences. And I think in a way, that is the ultimate test of these products, right? When you get to that point where they can be redeployed, they're not in the lab anymore. And that takes some time, that maturity. But I think we've now proven the point these things can work, and we're in that deployment phase and scaling phase of the business.
I mean, it feels to me as though like VR has been around for a long, long time. Like I can remember, was it The Lawnmower Man? The movie, you ever see that one?
I didn't, no.
No, it's quite good.
Okay, I'll check it out.
I mean, that must be like 20, 30 years ago. And people were talking about it then. It feels like, I say, it's a technology that's been around for so long without ever really kind of making it into the mainstream so much. So why is that, do you think? Like,
well, I think because the idea is so simple and compelling. But delivering it's really hard.
Right.
And that means delivering both in a quality that makes sense, in a form factor that makes sense, and at a price that makes sense.
And
I think often it does fall short of the expectations people have for it in terms of those things, unless you can relax those constraints. So think about consumer VR. It has to be, in a sleek little package. It has to be, cost you less than $400. It has to look really good, right?
Yeah.
And so far, no one's managed to do that in that package.
Yeah.
I think for us, we have different constraints.
Right.
So we have, customers who want to spend tens of thousands of dollars on a headset. And they're willing to put in place big server racks on one side, and they have people who are like trained users. And so when you're using it for a professional tool for a certain purpose, you have a different set of goals you can solve around. And I think you can actually deliver the promise of VR in those circumstances. Do I believe that experience will come to your smart glasses on your head?
Yeah.
I mean, sure, one day, but
not
in the next 10 years. And I can say for sure that we just know about the compute requirements needed for that.
Yeah.
That there's still going to be a big gap, I think, between the world of, let's say, smart glasses, which I think will become a popular mainstream product for consumers in the next few years, and the world of immersive VR, which has got much higher requirements for fidelity and bandwidth.
Yeah. And is your product the result of kind of recent technological advancements that have made it possible, or?
Well, we're always trying to pick things at the frontier of what's possible. So as I said, we're not constrained somewhere by price or weight. So we can pick the displays, the optics, etc., which are still N years out from consumer products.
Right. Okay.
So yes, we're at the absolute forefront of that technology. I think there's things too which are more on the software side of things that are more recent. So because we're linked to a big PC, what we can do is we can run a bunch of AI algorithms to do things which are quite power intensive and quite power hungry, which you couldn't do on a headset which was like standalone on your head. Okay. So we can use like software advances too, because we have the compute power to deliver that, given the architecture that we use.
Yeah. Okay. And you just mentioned AI. Like how important is that to you guys? Like how much are you utilizing that?
Yeah. So AI for us is kind of on the visual end of AI, and not so much on let's say the LLM end of things. What we're doing. And so, for example, one thing we're doing right now is we are having I mentioned the importance of those cameras, right? So how you can see the real world. And we're limited still on the pixels we have there. What we can do is use the PC itself to do AI upscaling of that content to make it look even sharper and even better in real time as you're looking around, because we have that. And that's a new feature that's come along in the capabilities come along in the last year or so. That's possible to do that really plausibly real time.
Yeah.
Another example would be, how do you separate out real and virtual things in the world? So this water glass sample, let's say I want to see this water glass against a virtual backdrop.
Yeah.
We can use AI to cut out the edges of the water glass and segment it out from the backdrop by recognizing objects that move around.
Okay.
So those kind of the kind of features you can deploy in mixed reality.
And you couldn't do that before. You could, but it was very, very labor intensive. And
we couldn't do it before. So the algorithms weren't there.
Okay.
And they're still very, very power hungry, the algorithms.
Right.
That's why they can only really run on big PCs. So I think we're at the frontier of what's just possible now.
Okay,
really.
So AI is enabling you to do more with...
Yeah, to do that new features that are more graphical features, if you like, of the headset.
Okay. All right. Interesting. And they're built in Finland.
Yeah.
Is there something about Finland that makes this more possible?
Yeah.
Because I believe Finland is, it's a small country compared to many others. But there are quite a lot of defense companies there, a lot of startups doing defense work. Is there a reason for that?
Yeah, there's probably two angles to that. Probably one is the natural geography of Finland, right? So it's got its big, long border to the east. And so they're very conscious about a need to have autonomy and self-defense. And that's it's a big thing as part of their culture. They believe in all the time. So just running through the veins, if you like, is that. And then the other side of things, you've got the legacy of Nokia. That was at some point an enormous employee, and most of the employees at Varjo now, at some point in the past, would have worked at Nokia. They're working with cameras, screens, electronics, mass production, all those kind of things. So that sort of bedrock of capability that comes along, and various ones that sprung out that our founders from Varjo came back in the day from Nokia as well.
Okay.
So I think those two things, that sort of the wish and the capability together, create that ecosystem you mentioned around defense.
Okay, yeah. And I mean, it's a product that's not a defense product. Exactly. It can be used in other industries, but predominantly the customers are defense companies. Are there any kind of like moral considerations which the company like looks at when they're designing new products?
Yeah, so you said it right. So the product is a consumer off-the-shelf product technically. So when it's not a product which is a military product. Yeah, it's not a weapon. It has found a product market fit in a certain market with certain requirements, but the product itself is a headset integrated in a certain way. Yeah, and we're not deploying into operational environments. So we are really a training solution. So I think we're somewhere away, if you like, from the pointy end of defense. So I think we have fewer exposure to that kind of stuff. I think that there's some questions still about who you sell to in this world, right? And I think we sell to NATO countries and allied countries as well as part of that. Typically because the systems our customers are training on, like an F-35, are sold to certain countries as well. So we don't have to deal with necessarily all the edge cases of like countries you maybe not want to sell to or want to sell to because we're aligned around a certain base of markets. So I think the market focus is probably the biggest question for us.
Okay. And you're here in the UK. You're not from Finland.
I'm not.
I don't think. No. So what are you doing?
I'm occasionally mistaken for a Swede when in Finland, but on a good day.
But what are you doing?
Yeah. So I have the luxury to work with all these clever Finns, but based here still. So I'm back and forward to Helsinki every few weeks.
Is there a big presence here in the UK?
Not a big presence in the UK. So we have our commercial operations pretty much around the world. So the business is now spread commercially. I mean, it's not in Finland. It's all around the world. And so our biggest customers in the US. Okay. But all the engineering and product pretty much is out of Helsinki.
All right.
So I go there back and forth all the time. I think for a hardware product, actually, you do have to be hands-on because the things you've got to test and try. So it's not the perfect remote working job, but you make it work over time. Yeah. And it's great fun. I think I haven't got a strong background in this kind of hardware product beforehand, but I've learned a lot and I certainly hope to work in hardware products in the same way for a long time. Yeah.
Okay. And how's traveling back and forth to...
Have you been to Helsinki ever?
I haven't. No, I've never been to.
Well, I'd recommend it. You can either go in, let's say in July when the days are super long, and you can be out there having a drink at 11 p.m. and still feeling like it's sunshine, or you can go in January when it's super cold. You can go in a Baltic lake and in a Finnish sauna, and that's also fun as well.
Maybe.
Not commitment there. There's no promise there. Jump in the Baltic Sea.
So what are some of the kind of what does the future look like for Varjo? Like what's next for you guys?
Yeah, I think for us we've kind of found now like the core market for us. Now the question is how to expand outside that. So I think pilot training, both in terms of jets, helicopters, all those kind of things, I think is very clear. It works for this. Yeah. And adjacent expansion then is for us into civil aviation training as well. Right. So that's a world which is much more regulated. Hence quite a lot slower to move to things. But we're now seeing the first signs there of these headsets being qualified by EASA, by the FAA for civil simulation training. Okay. And that's also a big adjacent market to this.
Yeah, bigger probably.
It's big, probably of similar size actually in the end. Right, okay. I think that the training is it's probably less training per pilot in the civil aviation space, but there's more pilots, right? So it kind of adds up. Okay. That's one thing. So civil aviation. And then beyond that, you've got training for other kinds of military training, but outside the air. So think about all those ground-based scenarios. Be those people in vehicles.
You mentioned tanks
or trucks, etc. Or people thinking about training with light weapons, etc. All those kind of good training scenarios where there's actually much more volume of that kind of training. Right. And right now there's many fewer opportunities for virtual training as well too.
Yeah. Okay. And what are the plans in terms of the hardware itself? Like any new products on the horizon or?
Well, obviously we don't tell about the absolute new products that come along, but typically speaking, we have a new headset product every 3 to 4 years. Kind of time, which is longer than the consumer life cycle because our customers too, they want to integrate things on their side. So they actually don't want a new headset every 12 months, right? They want to spend time to get it right before the next thing comes out. And so you could expect a new headset from us, in a couple of years' time, which would be catering this market, but also to those other markets I talked about, like expansion opportunities as well.
I mean, the headset, it looks pretty good. It's very, I mean, how important are the aesthetics to your customers, or do they not care about that?
Yeah, this version I'm showing you here actually is not the most recent version. We have a version we brought out just a few months ago. It's got slightly different aesthetics. It's more tuned to the military use cases we have right now. This is one from before. They don't really care about the aesthetics particularly. They care about the ergonomics, I think. So as you'll see, it's quite a big device, right? In terms of like overall weight. It's probably a kilo this weighs overall. Yeah. And so things about the... Of course you can, some cables there. The cables you wouldn't have in your head.
It's as heavy as it looks, isn't it?
It's heavy as it looks.
It's not.
But I think, so hence the question is, how do you make sure things float in your head in a balanced way? Yeah. So that's about how do you get the support, the padding, the corrections. So when you put it on, it's sort of nicely balanced around, so you're not feeling the problem is the front weight often. You don't want to have the front weight. As long as it's sitting here, it's actually fine. So they care about things like, how do the padding work to make sure you're both secure in the headset but not feeling too sweaty. How does the fit so it can be low on the back of your head. All those kind of things. How can you fit your eyeglasses inside it? All those kind of questions around ergonomics are important. So that's
more important,
I think that's a really important question because our customers use it for long sessions too, for maybe like 2-3 hours sometimes in a headset. And so it has to be, it hasn't got to look like it's light. It has to feel like it's light.
But obviously the aesthetics have been important to somebody because it does, like I say, look quite good.
No, and it's a great product. We had a lot of time on the design of the whole thing. And I think in a way we're a niche manufacturer, but bringing in the design values, if you like, of a mass market manufacturer to these things as well.
Okay. And should we want to find out more about you guys, like how's the best way to go about doing that?
Well, our website is Varjo, VARJO.com. And there's a bunch of examples of both the product specs itself, like what it does, but also the use cases too. So think about like what applications it's used in, what customers are having success with, those kind of things. That's a pretty good place to start.
Okay. All right. Thank you very much.
Pleasure. Yes.
Very nice to talk to you.
Not at all. You as well.
Whether you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.